Hey, welcome back to Engineers Workshop. I've been off a couple weeks doing something other than making videos. So anyway, back at it here in the shop. Apologize here, at day 414, the drawing of Ukraine is getting erased a little bit, kind of like the actual country. Anyway, so first item of business, I got a couple of stickers from other channels. First one, Stevie GTR, or otherwise known as the Anything Garage. I'm going to put him up here on the board. This is Steve Edwards. He's actually sending out replacement stickers. He had printed some original ones up and the printing didn't hold up so well and they were fading. So he sent, I guess you just call them warranty replacements. So got a nice fresh one up here that hopefully will last a long time. Steve's out of the UK. He's got a Myford Super 7B and a Tom Senior vertical mill. He does lots of car work. He's got a Ducati motorcycle. And one of the coolest things, he's got a recent project. He's building a hit and miss engine out of a scrap chainsaw. And I mean, I saw the picture of this thing and you can't tell it from the real thing. I mean, he's doing an awesome job. So that's the first one. And the second one is from a little channel you may or may not recognize. Right there, it's called Vintage Machinery, or vintagemachinery.org. It just feels so good to be helping out, you know, networking and helping these little channels grow by adding some subscribers. So Vintage Machinery is run by a gentleman called Keith Rucker. So I'm putting that up here. Keith and I have been corresponding back and forth on the rotary head mill. He just bought one. In case you're not aware, you know, so I can't even begin to list all of the equipment that Keith has, because basically if he wants it, he buys it. If he doesn't want it, someone gives it to him and he restores it. And more importantly, he will buy every option or every, you know, add-on that each particular machine has. And sometimes more than one. He'll buy 2 or 3 of them. So Keith was kind enough to give me a starting switch, a spindle switch, you know, forward, off, reverse for my 2D. I bought 2 of them and neither one of them is working correctly, you know, plus the original one that failed. So Keith was fine enough to give me a switch, still sealed in its factory bag. I mean, it's really cool. I'll show you in a minute, but got some other stuff to get to. I've got another piece of equipment. I've got a new table saw, new to me table saw. It's a Rockwell 12 to 14 inch table saw, kind of the unisaw on steroids. I will show you that, and I will show you what we're doing with the parts for the Skinner steam engine, and I will show you the switch that Keith sent me. So let's go check it out. Excuse the clutter. So this is the first item here. Kearney and Trecker. Arrow Heart switch, still in its factory sealed bag. Man, I wonder what 1964 air smells like. I wonder if it's better than our air we have today. I'm not going to open this up. I'm going to have to like sit down and crack open a beer or pour a glass of wine or something and kind of, you know, savor this moment. But that's been in that package for a good many years. At least since they've been assembling these in Mexico, which could be a long time. But I'll get that on the K&T, and that way the spindle can start and stop correctly. So back on this assembly. This is the slide valve actuator. In the last video, I turned this rod down. I'm at a consistent, I believe it's 891. Let me double check that. 896 and a half. This started out at 15/16 and was worn in the center, kind of like an hourglass shape because of the action going through this packing. So the plan is to take the brass outer packing nut and this bore at this end and bush them down. So these started out at a nominal 15/16. And I was able to find oil lights with a 15/16 OD, but I couldn't guarantee, once I cleaned these up, that they would, be a snug enough fit. So I got 1-inch OD and 3/4 ID. These things normally run like right at 1.03. This one's actually 1.01, 1.02. That way, if you have a 1-inch bore, this one's only 1.5 thousandths. So I'm going to have to cheat. I don't really get 1.005. Definitely not round. But anyway, I'm going to just put these in the lathe, bore them, press these in. That's an exact match for length. And then this one is going to take 2 over its length. And then bore the ID to be about 1 thousandths or so over the diameter of the rod. Now this one in particular, the outer end, it flared out because in operation, I'm going to put these together back in order. And then this packing nut goes in here against the packing. So in operation, the ball joint is connected at the outer end. And because this is receiving its motion in a slight arc, there's some side to side on this, and the side to side wiggle caused the outer end of this brass packing nut to be bigger than this end. So it's still under 1 inch, but these will clean up, press those in, actually turn all the packing out, and then I got some little spool of packing here. This is a 5/16 square graphite and braided packing material. And the object is, I believe, you cut this in little donuts, stuff them in there, and then the packing nut will give it the squish. So that was about, I don't know, 18 bucks worth for 5 feet of that. But let me show you the new saw, and then we'll get on, probably I'll do this one first. Here's the main table for the Rockwell 12/14-inch table saw, and the 2 extension wings which bolt onto either side of this. Most of you are probably familiar with the Rockwell or Delta Unisaw. It's kind of like the gold standard for cabinet saws and closed base. Trunnion pivots the entire motor and blade assembly to effect up to a 45-degree tilt or miter cut, and then there's a worm sector gear that drops the motor down, which controls the depth of cut. To give you an idea of the relative size of this, though, this is the contractor saw. And this particular Rockwell contractor saw has the full cast iron tabletop and very long rip fence. So this is the same top as the Unisaw. I had a Unisaw, remember, this is how big it was. I want to give you an idea of the relative size difference of these. So the extension wing, here's the split line for the extension wing. And here is the extension wing on the 12/14. I'm going to line up the split lines here. We've got an additional 10 to 12 inches in length and a good 2 inches in width. Yeah, probably 2 inches in width. And then let's compare the sizes of the main table. So the Unisaw main table front to back is 27 inches. Each wing is 8. And the overall width 36. The overall main table is 20, whereas the main table is 28. And the length is 38, and then each wing is 10 by 38. So we have 38 by 48. So we got 38 by 48 when this is fully assembled versus 27 by about 36 or 37. Quite a step up in size and weight. I can lift that, but I just barely. That's at least a couple 100 pounds. I think someone was telling me the entire top weighed like 330 pounds. It sounds about right. This motor was a freebie with the saw. The guy was getting rid of it. It's a 15 horse Century premium efficiency motor, 1800 RPM. And I believe I'm going to put this on the compressor. It's overkill, but if it runs, I'm pretty sure that the frame of the air compressor tank will take it, and that way I can take the explosion-proof 5-horse brake motor and just sell that. It's not really meant to be on a compressor, and I'd have to build a right angle bracket for it because that was a C-face motor anyway. So we'll get this running and possibly just put it on the Quincy, get that back up and running quickly. Let me just drive out from under this. So taking a little closer look, Rockwell 12 to 14 inch tilting arbor saw. A couple generations of electrical panels on it. Holder for something, I don't know what, probably blade wrench. And this originally came from the North Carolina School of the Arts. I'm gonna have to look up this serial number, that serial number there. And when you look at the trunnion design, it's just basically massive compared to a unisaw. I think that's a 12-inch blade on there. It can also, go to 14. And this I find really interesting. This is a flat belt drive, no V's. Should be nice and quiet. Bearings seem good. That's our full depth of cut. And this is our pivot. There's for a 90. Splitter mounts here. Sawdust deflector. I don't know if you noticed, but somebody fitted some sheet metal into the bottom of this to kind of help out the dust extraction. I'm pretty happy. I don't think that you can technically wear one of these saws out. So once I get the tabletop assembled and precision aligned to the travel, to the path of the blade, it should be a really, really nice cabinet saw. The T-slots, they're an interesting beast. Pretty much every T-slot in every piece of woodworking equipment is a 3/4 by 3/8. Now Delta does have a bar here to prevent the, it's like it's an actual T, so that the bar can't lift up. Most of the aftermarket ones are just 3/4 by 3/8 flat stock, and they drop in there. But the 12 to 14 inch table saw has a 1 inch, and then this is 1 1/4 over here. And so this uses a non-standard miter gauge, and I found one on eBay, paid dearly for it. But you know, they're rare, so needed to have a miter gauge. But pretty happy with that purchase. Still got to get this guy motor mounted on this. This saw will stay in the metal shop for miscellaneous wood cutting and crating and such. And the radial saw will stay in this wood shop. The 12 to 14 table saw will go back to the small woodworking shop, and I am downsizing that from an 18-inch beech table saw. I'll show you in another video. Okay, I have my packing nut in the 4-jaw chuck. I've indicated the OD within about 1/1000ths, and I will just start taking some cleanup cuts here until I get a straight bore, and then check progress. $963. $15 thousandths on the diameter. I should be at about 997 right now. Before I go any bigger, I kind of want to see if bushing will start to go in that. Probably should go just a hair more. That's interesting. My VFD faulted. I think that's going to be pretty good. So I'm going to loosen the chuck here. These two. Take this piece out, and then I'll be that much closer when I go to indicate it back in. Let's also scribe a line at 12 o'clock. Over to the press. It's important to have that little lead in because you don't want to be shaving the edges of the bushing off. Oh yeah, that's a nice fit. Beautiful. Back in the lathe. Okay, we're going from 0.750 to 0.892. So about 140 thousandths to come out of this bore. 100 thousandths more to come out. Let's do 30. There's that VFD faulting again. I wonder if it's temperature or if we're getting power blips. A little looser than my target. I can't exactly figure out why, but I'm not going to redo it. Try to do better on the cast iron guides inside the housing. The OD of this thing does not particularly pilot very close anyway. If it were, I would maybe try to improve that fit some. Final operation, I want to face this just a bit. Well, I got to repeat that same process in this bore. So this is going to be going together like this. Better. I mean, I blew past my dimension. I think I know what happened. Before that last cut, I bumped the dial, and then I came back and I advanced it another 1/1000 and a half, for a total of 3/1000, and I've got like 5, 6, 7 thousandths of slop instead of 1. But I'm going to shoot for better fit on this end. Like I said, this nut does not fit particularly tight in the bore, so this nut can move back and forth some on its own anyway. Checking out my 15-horse motor, and I have never seen a diagram, a low voltage diagram, set up like this with 3 leads connected to L1, L2, and L3, and then nothing jumpered. Normally I see 2, 2, and 2, and then the 3 are jumpered across, unless this is, I don't know much about Y and delta, but the high voltage is more typical 1, 2, and 3, and then you jumper, jumper, jumper. So my little VFD is not configured correctly that I can bring this thing up to a full 60 hertz, but I can bring it up to 30 hertz and then dial it up from there. So there's 30. And that's a full 60 hertz. So anyway, it does work. I'm going to proceed boring out a bushing to fit this shaft and put this onto the Quincy air compressor. Well, that wasn't really a whole lot to look at, but at least got me back into making some videos again. So I'll try to make some steady progress, get you another video each weekend like before. Weather is beautiful today, mid to upper 80s, very low humidity for this area of the country. So it was a pleasure to work today in the shop. So more on the steam engine over the week, and more on probably reassembling, aligning the tabletop for that 14-inch table saw. So I'll show you some videos of that going together, and we'll be back with you again next week at Engineers Workshop. So until then, as always, stay safe.